Today we're going to look at a new type of distribution and how our data can look in a graph form. And remember back in chapter 4, we were talking about discrete numerical data. And this discrete data had a graph, as you can see on my screen here. It had a graph that were in these bar shape values. This was a discrete distribution. And so now we are going to move into something called continuous data and continuous probability functions. So chapter 5 is just one page, but it's just to show you the cumulative distribution function and what it looks like. So when we learned about probability functions, probability distribution functions, we learned that all of the area under the curve has to equal 1. And so that's what it shows here in the graph A. And then graph B shows the probability that your X value of your variable lands between A and B, and it's some shaded area here. And so this continuous probability function that we're going to learn and use this semester, the only one we're going to learn about is the normal probability function. And so that is going to be in chapter 6. And it's going to be called the standard normal distribution. The standard normal distribution is a normal distribution, and the mean is always equal to 0, and the standard deviation of the normal distribution is always 1. And we can define it just like we defined it with the binomial. We can define it with this. X is described as the normal distribution with mean, whatever our mean is, and sigma. Now, the normal distribution has a particular one where the mean is 0 and the standard deviation is 1 for the normal. Distribution. Okay. In the z-score we learned about back in chapter 3, the z-score tells you how many standard deviations the X value is above, to the right, or below, to the left of the mean. So let's go back to that definition. The z-score is found by taking the X value, subtracting the mean, and dividing by the standard deviation. So in example 1, it says, suppose with our situation we have a normal distribution with the mean of 5 and standard deviation of 6. This says that X is a normally distributed random variable with mean 5, standard deviation 6. Suppose that X is 17. Then we take 17 and subtract 5 and divide by 6, and we get 2. This means that X equal to 17 is 2 standard deviations above, because it's positive, above or to the right of the mean 5. Notice that 5 plus 2 times 6 is 17. Now suppose X equals 1. Our z-score would then be 1 minus 5 divided by 6, which is 0.67. This means that X equals 1 is 0.67 standard deviations below the mean. And my apologies, this is a negative. A negative 0.67 standard deviations below the mean. Okay. And so 5 plus a negative 0.67 times 6 is approximately equal to 1. Okay. Summarizing, when z is positive, X is above or to the right of the mean, and when z is negative, X is to the left of or below the mean. Or when z is positive, X is greater than the mean, and when z is negative, X is less than the mean. So let's do the next, let's do the U-triad for number 1. So U-triad says, what is the z-score of X when X equals 1 and X is described as normally distributed where the mean is 12 and the standard deviation is 3. So we have z is equal to 1 subtracting the mean, which is 12, divided by 3 equals a negative 11 thirds. And that equals a negative 3.67. Example 2 says, some doctors believe that a person can lose 5 pounds on the average in a month by reducing his or her fat intake and by exercising consistently. Suppose weight loss has a normal distribution. Let x equal the amount of weight lost in pounds by a person in a month. Use a standard deviation of 2 pounds. So this is how we're describing x. Suppose a person lost 10 pounds in a month. The z-score when x equals 10 pounds is z equals 2.5. Verify this. Okay. This z-score tells you that x equals 10 is 2.5 standard deviations to the right of the mean, which is 5. Let's go ahead and calculate this. They lost 10 pounds, subtracting the mean of 5 divided by 2, which is 5 divided by 2, which is 2.5. So we verified that. Okay. Suppose a person gained 3 pounds and negative weight loss, then z equals what? So we would have they gained 3 pounds, so it was a negative weight loss minus 5 over 2 would be a negative 8 over 2 equals a negative 4. So z is a negative 4. This z-score tells you that x is negative 3 is 4 standard deviations to the left of the mean. Negative. Okay, suppose the random variable x and y have the following distributions. X is normal with a mean 5 and standard deviation 6, and y is normal with a mean of 2 and a standard deviation of 1. If x is 17, then z is 2. This was previously shown. Okay, read this in the last one. If y equals 4, then what is z? Y is 4, subtracting the mean of 2 divided by 1 is 2. So we just show that. This means that 4 is 2 standard deviations to the right of mean. Therefore, x equals 17 and y equals 4, both 2 of their own standard deviations to the right of their respective means. The z-score allows us to compare data that are scaled differently. To understand the concept, suppose that x distributed represents weight gain for one group of people who are trying to gain weight in a 6-week period, and y is normally distributed measures the same weight gain for a second group of people. A negative weight gain would mean a weight loss. Since x equals 17 and y equals 4 are each 2 standard deviations to the right of their means, they represent the same standardized weight gain relative to their means. So this is similar to in the assignment back in chapter 3 where I asked you to compare, I think it was Rachel and Betsy, and they were deciding who was happier with their score on the exam based on how their class scored. Let's look at the next few. Try it. Fill in the blanks. Jerome averages 16 points a game with a standard deviation of 4 points. So x is distributed, my hole punched it out, as normal with 16, 4. The z-score when x equals 10 is negative 1.5. Let's verify that. And we just verified that it's negative 1.5. This score tells you that x equals 10 is 1.5 standard deviations to the left of the mean, which is 16. And it's negative because it's to the left, it's under the mean. So I'm going to introduce the empirical rule, and then you're going to catch me back to the second part for 6.1 because this is a long lesson, so I want to make it into 2 videos. So the empirical rule states, if x is a random variable and has a normal distribution with mean mu and standard deviation sigma, then the empirical rule states this. About 68% of the x values lie between a -1 and a +1 standard deviation of the mean. About 95% of the x values lie between a -2 and +2 standard deviations of the mean. And about 99.7% of the values lie between a -3 and a +3 standard deviations of the mean. So I'm just going to draw them, and you can see them down here. So this is about 34% and 34%. And then we add 13.5% here and 13.5% here. And then between the second and the third, it's about 2.35% and 0.15%, which this here totals 2.5%. And then this is that 2.35, and this is that 0.15. And this again totals 2.5%. So this is where we've talked about what's unusual before. Anything to the left of 2 standard deviations is called unusual, and anything to the right 2 standard deviations is considered unusual. We're going to use these concepts in the rest of the semester actually to help us build on deciding if an observation is unusual or not. So catch me back for the second lesson to 4.1. I'm sorry, to 6.1.